We are given a function, y equals the definite integral from 0 to x of cosine of t dt. We're asked to find dy dx two different ways. First, by directly applying the fundamental theorem of calculus part 1, and again, by evaluating the integral, using the fundamental theorem of calculus part 2, and then differentiating the result. The idea here is to more convince us that the fundamental theorem of calculus part 1 really works and gives us an easy means of differentiating this function. Because just applying the fundamental theorem part 1 says dy dx is cosine of x. Okay, so let's use the fundamental theorem of calculus part 2 to rewrite my original function. So I'm taking the definite integral from 0 to x of cosine of t dt. So I need an antiderivative for cosine, which we know is sine. So that would be sine of t evaluated from 0 to x. All right, so now I plug in my balance. Sine of x minus the sine of 0. Well, the sine of 0 is 0. So y, written down like this, really was just sine of x. Now I can just differentiate. The derivative of sine is cosine. And I get the same thing both ways, but I certainly worked less hard this way. But I bet some of you are thinking, well, I understand this really well, so I could just do that every time. And the answer is no, you can't. Because what if we had a much more complicated looking function? Maybe someone defined a function y equals, and then the definite integral from 1 to x of sine of t divided by t dt. We would need to find, for that second approach, we'd need to find an antiderivative of sine t over t. And that doesn't look like too complicated of a function. But we don't know a rule by which to find its antiderivative. And even after you take calculus 2, you won't know a rule for that because it's what we call a non-elementary integral. There is no nice antiderivative of sine t over t. There has to be one because it's a continuous function. We just can't write it down in a nice way. But we can write it down like this. This is literally an antiderivative for sine t over t. And if I wanted to take its derivative, and by it I mean this function, take this function's derivative, well, use the fundamental theorem of calculus part 1, and there it is. dy dx is sine x over x.